So, good afternoon, everyone, and welcome to this mushroom research webinar, which is focused on producing mushrooms in an environmentally sustainable way. My name is Donal Gernon, and I am the Teagasc Mushroom Advisor. Mushroom producers in Ireland and all over the world are heavily reliant on mushroom peat casing. As pressure increases to stop extraction of peat in Ireland, we look at possible casing alternatives tested based on research carried out in the UK and the US. We'll also introduce you to the Teagasc S-Transit project, which has recently commenced and aims to support a sustainable transition away from peat use in mushroom casing. In the second half of the webinar, we will focus on mushroom pest and disease research. This is a topic which is of huge interest to growers, as disease was widespread in Ireland, especially in the second half of last year, which caused significant crop loss. This section will have 2 key speakers and 3 short Teagasc research project updates. Hopefully there will be some key advice from this research which growers can implement on their farms immediately to prevent pest and disease infection. So shortly, I'll pass you over to Dr. Ralph Noble from Biotech, who will discuss potential alternative materials to peat in mushroom casing based on the research he conducted. Ralph has huge experience in this area, which is very useful for everyone to learn from, as it will give us a direction on where we should focus our work on future mushroom peat alternative research projects. At the bottom of your screen, you will find a Q&A box, and there you can ask your questions as they arise throughout the webinar. I will put these questions to the speakers after each presentation. In the chat function, I will post a link for those of you in the audience who wish to register for IASIS, BASIS and Narosso points. This link will bring you to a survey where you can fill in your details so I can register you for points. If you're having technical difficulties throughout the presentation, don't worry. The event is being recorded and we'll put it on the Teagasc Horticulture Development Department YouTube channel after the event. So without further ado, I'll hand you over to Ralph to begin his presentation.
Yes, good afternoon. I'll try and share my screen.
Perfect, thank you. Thanks, Ralph.
So potential alternative materials to peat in mushroom casing. So the Irish mushroom industry uses about 120,000 cubic meters of casing per year. And of course, lots of other countries are dependent on Ireland as a source of peat in casing. Countries like Australia and New Zealand import peat from Ireland for mushroom casing. And in recent years, this is mainly deep dug wet peat, because deep dug wet peat has been found to give very good yields of high quality mushrooms, also for large mushrooms like portobellos. So the industry in many countries has become dependent on wet deep dug peat as its casing material. I'm actually old enough to remember when we used milled peat, a dry peat, probably going back 30 years. So instead of wet casing, growers would wet the casing themselves from dry peat. But it was found this material is more difficult to water, and the quality wasn't as good as with wet dug peat. So the industry very quickly changed from milled peat to wet deep dug peat. So what is a good casing material? Why do we choose wet dug peat as a casing material? Well, it has a high water holding capacity. Casing material has an even higher water holding capacity requirement than pot plants or other growing media. Other growing media have a higher requirement for air spaces in the material. Mushroom casings has a particularly high water holding capacity. That's why it's been particularly difficult to replace peat in casing, whereas some other sectors have moved out of peat because pot plants the roots need more air. It's been much more difficult for casing material. We need a low salt content, so any plant nutrients in the material are undesirable. It mustn't encourage molds, particularly green mold is a big problem in casing trichodermas. The cost must be low. It's possible to grow mushrooms on things like vermiculite, but they're much more expensive than peat. So the cost always has to be taken into consideration, and obviously it needs to be available in large enough quantities, close enough to Ireland. There are materials made from, for example, tropical waste like sugarcane bagasse, but they're just too far away to be viable in Europe as a casing material. The casing mustn't stick to the mushrooms. Cleanness is an important quality requirement for mushrooms, and obviously the material must be free of any physical or biological contaminants that could affect either the growth of the mushrooms or the marketable quality of the mushrooms. There's been a lot of experimental work over the years on finding alternatives to peat. This goes right back to the 1970s. Work in Ireland was done in the early 1980s on looking at peat substitutes. A lot of this work was on partial replacement of peat rather than complete peat replacement. So some of the experiments or the work I'm going to present is on partial substitution rather than on complete replacement of peat in casing. First of all, composted pine bark. This has been looked at for many years, going back to the 1970s. It's possible to grow mushrooms on composted pine bark. You can see in the top right there a crop growing on 100% bark. One of the problems with bark and other organic materials is they're prone to molds, particularly green mold. Bark is a slightly acid material, and the organic matter in it is suitable for trichodermas. So there's a problem suppressing molds, particularly green molds, on things like pine bark. Coconut fibre can also be susceptible to green molds. It can be shipped over long distances in these in this compressed form, quite widely used in the soft fruit industry as a growing media. But there's obviously competition for this material from other sectors like soft fruit. So not a cheap option if you're looking at a replacement for peat. Again, it's possible to grow mushrooms on coir, but there are some disadvantages with using that material. The paper industry wastes, certainly in the UK, a lot of byproducts are produced from the paper industry, around 300,000 tonnes a year. Quite a lot of work was done, particularly by Fred Hayes, a guy called Fred Hayes, in the 1970s on using paper wastes in mushroom casing. Again, we can grow mushrooms on them, but they are rather prone to mold, not so much green molds, but other sorts of molds, coprinus. You can see here a crop growing on paper waste, but there's a mold growing on the casing material. Spent mushroom compost. Quite a lot of work has been done on recycling spent mushroom compost into fresh casing. Again, particularly if it's leached, if the salt or the nutrient content can be brought down, it can be used as a casing material. Problem is how to leach the material and what to do with the leachate. Possibly more promising is spent casing. So just reusing the casing material, most of the salt or the nutrient contents and the underlying compost. So the spent casing can be recycled. Just stripped. There are machines for stripping off the casing layer, and then that can be re-wetted and used in casing. So there's a crop here on the left growing with 25% recycled casing. We found that we can add about a third of recycled casing with no effect on the yield or the quality. Once you go above about a third of recycled casing, the residual salt content is too high, and the yield starts going down. The other problem, of course, is this relies on a peat-based casing in the first place. It's not clear how this would work if we were recycling a peat-free casing. But certainly in terms of peat casing, we can recycle about a third without any detrimental effect. And of course, this is with cooked out casing, so that there's no carryover problem of pests and diseases. It only really works if the material is pasteurized at the end of the crop. Green waste compost is quite an abundant material, and there are quality standards in the UK. There's this PAS 100 standard for compost. The problem is this standard isn't particularly rigorous. It still allows a certain level of contaminants, and these wouldn't be acceptable if it was being used as a mushroom casing. There'd have to be much tighter quality restrictions and specifications on composted green waste if it was going to be used as a casing ingredient. The PAS 100 standard is basically just a waste avoidance scheme, so that the material is no longer classed as a waste, and it's suitable as a soil amendment, but it's not really strict enough for professional grower use. So if green waste compost was to be used in mushroom casing and probably other professional growing media, there'd have to be a more strict specification on what's in it. It's possible to grow mushrooms on green waste compost. This is a crop growing on 50% green waste compost, providing the material meets certain quality standards. It can be used, but that material isn't yet available to that standard. Other sort of byproducts can be used as in casing. This is granulated rockwool. So the glasshouse industry, cucumbers and tomatoes, grow their crops on rockwool, and then this is a spent waste. If it's granulated, it's possible to grow mushrooms on that material. We produce about 10,000 cubic meters of granulated rockwool, so it's not enough to replace all of the peat, but it could make a contribution in a peat-free casing material. Of course, there are mineral materials that are used in casing at the moment, like sugar beet lime is a byproduct from the sugar industry. So it's a precipitated form of limestone. So that's used at about 10% of the casing material. There are other clay and silt byproducts. Dewatered clays are a byproduct from the sand and aggregate industry, and again, they can make a proportion of the casing material. This is actually an Australian grower who is using a mixture of peat and clay casing to grow mushrooms, and it produces good quality mushrooms. So just looking at the properties of the materials that go into casing, as I say, water holding characteristics are probably one of the most important characteristics of a casing material, and these curves show how different materials hold on to water as we increase the matrix potential. This is like the suction, so we're applying an increasing suction on the casing material. So if the graph sort of move from right to left, so if you start with a saturated material, and the bottom right hand corner, say about 80% by volume is saturated, and then as we increase the suction on that material, the moisture content obviously goes down, and it follows this curve upwards, and the curve is different for different materials. So the black line shows the desorption curve for a wet dug peat. So we're starting at over 80% at saturation, and then as we increase the suction on the material, it goes down to about 40% by moisture. What's interesting here is that some materials like used rockwool or wood fibre, they're very good at holding on to water when there's no suction applied. So in the saturated material holds a lot of water, so they're almost as good as wet dug peat when they're saturated. However, when we sort of apply suction to those materials, they don't hold as much water as peat. So that you can see they go to the left much more than the black line. As we increase the suction, the wood fibre, the dotted line, and the red and the blue lines, they're holding less water by volume than the wet peat. However, if we look at sugar beet lime and green waste compost, they're kind of the opposite. So when they're saturated, they don't hold as much water as peat. They only hold about 60% by volume of water. But if we apply a suction to those materials, they hang on to the water very well. So so if we apply a suction, you can see there that horizontal line, minus 10 kilopascals. So when we've applied a suction, they actually hold more water than the wet dug peat by volume. So what's interesting then is perhaps make blends of materials that hold water well when they're saturated, with a material that holds onto water well when it's being under suction pressure. So, for example, a clay mixed with a wood fibre might make a better material than just those materials on their own. So we can see that in the next slide. So this is actually casing made out of 70% bark, 30% filter cake clay, and produces reasonable crop of mushrooms. So perhaps blends of materials that have different properties work better than individual materials that on their own aren't as suitable as peat. So as well as individual kind of experimental materials, there are a number of commercial developments underway at the moment in Europe. First of all, at the top there's this Cormo material made from maize stalks. So it's made from maize residue. It goes through some kind of physical and fermentation process to make it into a growing media, and I think that is being tested now as a casing material, and reasonable mushroom yields are being reported from that material. New Phos is another material made from sort of waste plant materials. Things like fermented grass is used to make this new Phos material. So it's again a sort of fermented plant material, and that's currently under evaluation in a European project. Sphagnum peat moss is unlike peat, which degrades over thousands of years. The sphagnum peat moss is really just the surface layer of sphagnum on the peat bogs, and can be harvested at sort of 4 to 5 year intervals. And the regrowth of the sphagnum moss means it's a more sustainable source of growing media than peat bog removal. So providing the sphagnum is harvested at long enough intervals, it can regenerate. And again, this has been used in casing trials, and produces reasonable yields of mushrooms. What isn't available yet is any sort of formal comparison of these materials and how they compare with peat in sort of independently verified trials. That's something that still needs to be done. Just some problems that can occur when we try to replace peat with other materials. I've already mentioned the importance of cleanness. So dirty caps. I know things like perlite and vermiculite can have a tendency to be attracted to the mushroom cap. Certain types of bark can do that as well. So that's a big negative in terms of quality. Some materials can have a tendency to produce leggy or early opening. They don't produce the nice, large, dense mushrooms that we get off wet dug peat. Also a tendency for some to overpin. So although the yield might be all right, the quality isn't, and we just get lots of small mushrooms. And I've already mentioned the problem of spotting, of green mold, and this can result in cap spotting, like bacterial blotch. So the potential for causing disease problems also needs to be looked at. So just here a very brief summary table of perhaps some materials that I would regard as suitable or potentially suitable, and others that are not really in the running. So obviously materials like lime, which is already used, lime, sugar beet lime, clay, these can already be used as a proportion of the casing material. There's certainly an upper limit to how much you can put in there. Probably 30% would be a maximum. Otherwise, the material is just too dense. There's a number of potentially suitable materials. I've already mentioned the granulated rockwool, coconut fibre, spent casing. As I say, there's a problem there in recycling peat. It would have to be a spent casing from a peat-free material. Green waste compost, I've put PAS 100, but it would have to be to a standard higher actually than PAS 100. Certain types of bark could be used, and I've mentioned those commercial developments, Cormo, Newfos, and the sphagnum peat moss. There's some other materials that are less suitable for the reasons I've already gone through. Digest states have been looked at, and sugarcane bagasse, and a number of other materials are just too far away really to be viable as European casing material. And finally, although it's possible to grow mushrooms on non-peat casing, we don't know exactly what the effects on the yield and quality are, yes, from using 100% non-peat casing, but that has to be done in the background of strong import pressures, particularly from Poland, and I'm not sure that the Polish industry will be too interested in growing peat-free mushrooms, and there's Polish mushrooms here. The one on the right is actually called Bioplanet, Bicharki Bioplanet. That's totally misleading because they're grown on peat. So there's no indication yet that the Polish industry is going to go to a peat-free mushroom. So that has to be taken into account when any pressure is put on the industry to move to a non-peat casing. What about the imports that are still going to be grown on peat? Okay, so I hope that's given you an overview of what's possible, potentially possible in terms of replacing peat in mushroom casing. So
yeah, thanks a million for that, Ralph.
Yeah, thank
so we just have a question here. So on your work in relation to your research, is there any further work required to sterilize recycled casing other than the room cookout?
Well, as I said, the work on recycled casing has been done with peat casing. What's going to be interesting is, when we go to partial or full replacement of peat, how well can we recycle those materials? Are they viable in a recycled? Because if we can keep on recycling a third of the casing, that means we don't need as many fresh raw materials, which might bring the cost of looking for other materials down if we can recycle them to some extent. So that hasn't been looked at all. All of the recycled work's been done with peat casing. There's no reason to think that white would be any different.
I just have a question myself, Ralph. In terms of all the different materials that you've looked at, I know the materials that you've looked at has been blended with peat, but what have you seen has been the most potential, or in terms of yield and quality, that is most similar to what we have, what we're using at the minute?
Yeah, I would say the blends of material, a sort of very fine mineral material mixed with an organic material probably is better than just relying on a single material like bark or wood fiber. I think the blends of materials are more promising because you get this benefits of different properties interacting. I think that's a more promising approach. Maybe the Cormo or the new FOSS will make an impact, but I'd be very surprised if they're going to deliver the yield and quality that we get with wet dug peat. Maybe blends of those materials with other finer particle materials might be better. But I haven't personally seen those materials, so I'm just going by what I've read.
Just a question coming in from James O'Brien. Do you need to add pupad to these products to stimulate pinning, or is it needed? No,
I've never seen that needed. I think most of these materials have a natural population of Pseudomonas putida. All the work I've done on 100% peat-free casing, even things like vermiculite, I haven't added Pseudomonas to them, so they seem to get inoculated naturally. So I don't see any need for inoculating them to get initiation or mushrooms.
Okay. I don't see any other questions just coming through here at the moment. So I want to quickly remind for people that was late joining the call, if you want to register for BASIS, IASIS or Noroso points, there is a link that is on the chat function. So if you wouldn't mind clicking on that link and filling in your details so I can register you for points. So without further ado, thanks for that, Ralph. We're just going to
another question over there,
yeah.
Donal, in the question and answer.
Yeah,
you might want to address.
Yep, sorry. So do we know environmental footprint of these potential alternatives, i.e. greenhouse gases, etc.?
Yeah, that's a good question. I mean, it's going to be more important for materials that come over a long distance, like coconut fiber. That's imported from Southeast Asia. So yeah, as I say, it can be compressed, so the transport impact can be reduced. But yeah, certainly if you're transporting materials, or if there's any energy needed into grinding them or processing them, that has to be taken into account. Yeah, so that the carbon footprint obviously has to be calculated, and there will be one if there's some kind of mechanical or energy process that it goes through before it's ready for growing mushrooms.
Yeah, look, it's a very important aspect. Like, there's no point in us finding an alternative that's not environmentally sustainable. So yeah, it's a very good point. So yeah, so we're going to hand it over now to John Peckia. So John will speak about wood fiber products used as peat alternatives in casing. So John is a mushroom research professor at Penn State University, and he has huge mushroom research experience with numerous publications. So growers in the US are currently facing difficulty sourcing mushroom peat, and this has accelerated this research for John. So without further ado, I'll hand you over to John to begin his presentation.
Thank
Hi,
you,
John.
Can you hear me?
Yep, perfect.
Perfect. Okay, let me start my. And we're still good? You see the slides?
Yep, it's just coming up there. Perfect.
Okay.
Off you go.
Okay, well, thanks, Lael. Appreciate the offer to talk with the group in Ireland and the UK. For those of you that don't know me, my name is John Peckia. I'm an associate professor in plant pathology and environmental microbiology at Penn State. This is the department where the mushroom program is housed. I've been working, I guess, in this capacity of some sort for the last 17 years now. And at the university, I am the director of the mushroom spawn lab, which is a little bit of a misnomer. We have a spawn lab. We don't sell spawn, but we maintain a pretty vast culture collection and sometimes make our own spawn depending on the research. Also the director of the Mushroom Research Center. So at Penn State, we're lucky to have a facility that's dedicated for cultivated mushroom work. Most of our work is agaricus, not all, but the majority of what we do is agaricus related. At the university, just to give you a little bit of a background, we have 2 small phase 1 bunkers indoors. That's the picture in the top right. We have 2 small phase 2 tunnels as well. And then we have 9 growing rooms, climate controlled growing rooms. In the growing rooms, we grow in these little gray tubs so we can do replication and different experimentation setups. Depending on which room we're looking at, some of the rooms will hold 36 of these tubs, some will hold 54. And most of the work we do has been looking at production efficiency, substrate utilization, looking at different raw materials, both in the compost, as well as the casing materials over the last 30, 40 years. I'm not going to talk about everything that we've tested. Dr. Noble actually touched on most of the things. We've probably tested similar items. What I'm going to do primarily is talk a little bit about one particular product that I've been working with for the last year and a half. It's not a unique product. I think just the processing and the way it's made varies from company to company. So we also do some fly research here. You'll hear Dr. Wolfen this afternoon. We've had some fly issues. We do not do the fly research at the research center. We can't contain them. So that work is done with the entomology group that he's part of. In case you're not aware, the reason Penn State is, does have the program we do, we're located in central Pennsylvania. We grow in Pennsylvania almost 2/3 of the US mushrooms. So it's very heavily concentrated here in the Northeast. California, all the way to the West Coast, is the second largest, but they're only about 13%. And then there's some states scattered around the country. Now, interestingly, you just heard Dr. Noble, and you have the experience working with the black peats, and that's primarily what you grow on. The American growers primarily use that sphagnum peat, the blonde peat. So if you look at that scale on the left, the blonde peat is a much younger peat, much different physical chemical characteristics than the black peat that you're used to. And it is harvested kind of a very different system. It's not a deep dug. It's pretty much, they dry the surface and break it up and vacuum it kind of layer by layer off the top. So the characteristics are quite different. I know I personally, we've played with the black peat here at the university. Some of the growers will incorporate some black peat into their sphagnum. But again, because of transportation, costs are typically prohibitive to go very high in percentage. We do like the characteristics it gives to the peat to give us better structure. I think you get nice quality, a little larger mushrooms with it. But primarily, the US growers use a blonde peat that we then buffer with ag lime, potentially sugar beet lime, hydrated lime a little bit to give some different characteristics, but primarily blonde peat. And this map shows you, this is Canada. The bottom right where it's kind of clear, that's Northeast US. So you can see the concentration of the peat bogs in Canada. And even though blonde peat is, if you look at it, maybe more sustainable because it's not the deep dug black peat, there's been a lot of environmental concerns about even harvesting the blonde peat because these peat bogs act as a carbon sink. And as soon as we disturb them and bring the peat moss out to utilize it, whether it's for the horde industry or us, we're releasing increased amounts of CO2 and carbon into the atmosphere. So there's been a lot of environmental pressures on the Canadian peat industry. They do a really nice job of, as far as sustainability, of kind of revegetating and getting these bogs back to a high vegetative growth after they've harvested, but they can't do much about the CO2 emissions and the carbon emissions. But that's not really what drove this. The historical research that we've done at the university has always been related to the concern about a supply of peat, whether it's running out, which I don't think is reality, but the idea that potentially environmental regulations could deter it, the harvesting. But really what happened to here, the US industry here last summer, one of the major peat suppliers located in Ontario, Northeast Canada, that provides, I've heard estimates of anywhere from 1/3 to 40% of the peat coming into Pennsylvania for the mushroom industry, in the middle of the summer told the industry that they were no longer going to be shipping peat across the border to the US for the mushroom growers. Part of it's a supply demand, maybe related to COVID, probably, but that put the industry in a really bad situation quickly on trying to figure out what they can use. And the research we've done historically has always been looking at what can we use economically, the same bullets that Dr. Noble was talking about. What's economical, water holding capacity is good, and all these different things. The emergency situation that we kind of got put into quickly made us reassess it a little differently, looking at, what's okay, what can we do at least in the meantime. And a lot of what Dr. Noble said, I agree with as well. I don't know if we have something that's a peat replacement right now that's economical. Yeah, we've seen grown mushrooms here on perlite without peat, but it's extremely expensive. But I think supplementing the existing peat supply with some of these materials is the option we're looking at. And Dr. Noble went over most of these products that we've tested as well over the years. I will say that we worked with some of the recycled casing here. And again, our casing is the blonde peat that's buffered with lime. And with our recycled casing, with the experience I did a few years back, the salt levels were high that we couldn't incorporate much of recycled casing back in without adversely affecting yield. So last spring, a company approached me about testing some of their products. They have made wood fiber products, they're proprietary blends, so I don't really know the specifics of what these wood fibers are, how it's processed, but they have a lot of different blends they wanted us to test. They're using it for the horde industry. They wanted to see how it would work for us for the mushroom industry. So what we did, they actually provided me the blended product because they were concerned about how their product would blend. So I gave them our sphagnum and our limestone. They made the blends up, and we decided to go for the first round at 3 different rates. And what you're looking at here is the control, which is our standard peat, and then a 20% of product 1 up to 40, and then on product 2 we went 20, 30, 40% as well. This is the first time using this product, and what we saw is during the first break, if you look at the control, the top row, treatment number 2 picked as well as that, and most of them picked relatively well, except for product number 7 was very delayed, which impacted the first break a lot. And I'm not sure what's inhibiting the fruit bodies to mature with that treatment, but we definitely saw a delay that we ended up seeing picked up in second break, where you see a much higher yield in second. And again, you can see control second break picked really well. Overall, that last total column, what you're looking at there is, now the ABs don't matter much to you. That's whether it's statistically different or not. But you can see none of this products 1 and 2 at 20, 30, 40% picked really near as well as the control. And one of the things we saw with this, we only went 2 breaks, is we were seeing quite a bit of green mold popping up with this product. And I saw it on, I think, probably every tub of any of these treatments, but I did not see it in any of the control tubs, which is rare. Actually, we don't get cross-contamination even, but, and I'm not saying it was a trichoderma, the aggressive trichoderma. I don't think it was, but it's still, we were seeing popping up in late breaks. We didn't sample and isolate and work on that. So then we went to a second trial where they gave me other products to look at, some of these other wood fiber products that they use. They wanted to push it a little more. So we went 40 and 50% of 4 additional products, again, comparing to our control. The yields weren't as high. We had a little bit of humidity control. The first break was really low, I thought, but they were relatively consistent, and we didn't see much different from the treatments versus the control. One thing we ended up seeing, and it's maybe more pronounced, whoops, here, is between first and second breaks, if you look at the control, and then you look at treatment 2 and 3, we saw a much quicker drop off on second break. compared to the control. And I think maybe one of the factors that led to that was that the product handles very differently. Anytime you start adjusting your casing material, if you've tried any of this, you can't water the same as you typically do very often, and you have to interpret the growth differently. And I think, like Dr. Noble mentioned in one of his last slides, you get overpinning, and I think we saw some of that with some of these products, that with the overpinning and some clumping, we had more bed damage when harvesting first, which impacted later breaks. So I think that's why we saw more of a decrease in the second break on this trial. We didn't see as much here, probably because first wasn't as heavy, so we didn't see as much bed damage, but we still saw it, and it handles much differently. So the yields were relatively similar. Again, our control was the highest, but if you look at product number 5, which is treatment 6, which picked 26.7 compared to 27.3, they were pretty much the same yield. And treatment 8, 40% of product 6 was also very similar. We did all of this prior to the announcement coming out of Canada that they were no longer going to provide this one company, large company, peat to the U.S. growers. So then there was a rapid, I guess, hurry to look at what can we do and what of these were the best if they wanted to try it. So growers started actually incorporating some of these products themselves into their houses. As we started testing a little further with one of their products, and this is, I think product number 5 was on the last cropping trial that did the best. So we just ran another experiment looking at this as well as a few other products, but I'm just going to show you for the wood fiber results. And again, if you look at the control versus a 20% supplement, it had no impact on yield. 30% we started seeing a decrease, and I think with this product, I'm not sure if we can really go up much higher than 20-25%. I like what Dr. Noble said, actually. With one of his trials, he said it presented a reasonable crop of mushrooms. And I think that's important now for the growers. They're to the point that I think they're willing to accept maybe a slight decrease in total yield to extend the life of the current supply of peat as they're trying to figure out what to do. So, right now there are growers using this product. I'm not sure how many, and they're testing it in their own houses. I will say with this product, I had a couple concerns. Some we're testing right now. One is the green mold that I saw. I don't know if the trichoderma was in their mix to begin with, the way they handled it, and it came in on the peat, or if the mix was just more susceptible to trich. So I have a student right now doing some work in the lab where we're inoculating some of these different blends to see if there's a difference in susceptibility. Another concern I have, not as much with this product, but it's food safety. So anytime we start altering that casing material, we know that there's a casing microflora there that one can help suppress some foodborne pathogens, help suppress some mushroom pathogens. But at the same time, some of these products have to be safe to grow a ready-to-eat product like a mushroom on. We had a company contact us recently who sent a product, and when I looked at it and asked them more details about it, it's a product that would not meet the current food safety regulations in the U.S. There were a new rule that was passed about 4 years ago. It wouldn't be allowed to be used even for the mushrooms because of potential food safety concerns. And all the work we've done historically, and really what we've been running on hard for the last year or so, is looking at the yield. We're not really looking at all about the quality or the shelf life. That can be done follow-ups. Maybe some of the private companies are doing this themselves. But anytime, as you know, that you start stressing your mushroom, especially if it's water stressant, you may have an impact with yield and quality. So the yield may not show it. You might have a bunch of small mushrooms that are light and may not have a very long shelf life with it. I wanted to show you this. Dr. Noble actually mentioned this earlier. This is the picture on the left. If you can see it, this was a test we did with a paper product that actually yielded pretty well. But again, anytime we've historically looked at some of these paper products, we sometimes see these molds, and this is a similar thing here. It's kind of a close-up to show you this kind of gray fuzzy mold growing on the casing. I'm not sure if it impacted yield much, but it's a concern for us. We didn't do any work to further investigate what that actually is. The picture on the right, this is just some of the tubs in the one trial we did with that wood fiber the first time, and the pink purple tag, the one you see in the top left and the one in the middle, this is going in the first break and shows you this delay that we saw. And it's very prevalent. I think this experiment had 6 replicates per treatment in the room, and all 6 of these tubs were obvious, delayed by several days coming into first. So there are some issues with it. I wanted to just show you two slides from previous work done in the food science department. I know you all work with the dark peat. One of the concerns I have when we start messing and altering the casing materials, what it's doing to the microflora. And your dark peat has, this is some traditional bacterial work, total bacteria, actinomyces, and yeast. The red being the light peat that we use, and the blue and the green being the dark peats. It shows you differences in microbial communities, and that the blonde peats has a much higher population than the darker peats, which you would kind of expect. But once we start incorporating, especially at higher percentages, some of these inert materials or processed materials that may be heat treated or whatever else, it is going to alter the microflora. And one concern I have is not only what effect that has on the mushroom pathogen surviving. I think there was a publication that came out of the Dutch group just last year that showed that casing microflora affected blotch development. We think it also probably will affect trichoderma development. And this just shows you, this is an old study done 15, 16 years ago by a Ph.D. student, showing you what happens if you take peat moss and you sterilize it. Not that we do that, but the red shows you unsterilized peat after you inoculate Listeria. These red and green lines are Listeria numbers. And in a sterilized peat, Listeria inoculated into it flourished. There was no competition, so it did really well. In a natural peat with a high microflora content, we saw that the Listeria numbers decreased pretty quickly. So this is an absolute related to any of the specific materials we're testing or thinking about testing, but this is always something that's a concern in the back of my head. So that kind of concludes just kind of an overview of what we've been testing. I'd be happy to take any questions that you have specifically related to the wood fiber or any of the other experiences we've had, looking at different alternatives. But again, I think Dr. Noble's right. Right now, I don't see a replacement. I see a potential supplement, 20, 30%. The 40% didn't yield too bad, but then we started seeing more trichoderma issues with it.
Thanks, John. Yeah, that's really interesting. To be honest, I think there's a lot we can all learn from the approach yourselves have taken in America. The fact that you have faced already a challenge in sourcing peat and how you reacted, and I think we'll have to learn a wee bit from yourselves, and that we may have to go down the same road ourselves. Hopefully not in the immediate future, but there is always that possibility. So just have a question coming through here. So, hi John, do you know what species of trichoderma it was and what species of tree that the wood fiber came from?
I would say no to both. So the species of trich, we did not isolate this to see. My gut feeling is it wasn't aggressivum, but I don't know. So we weren't focusing on the trichoderma at that time. We are focusing a little more on it now. So ask me in a few months, I might be able to answer that question. And regarding to the tree species, no, the company that is providing these wood fiber blends has multiple different proprietary blends, and it's something they may share with me, but they did not tell me specifically what is in each one. So I don't know the tree variety. Okay. The interesting thing, one thing Dr. Noble said is about the pine bark being utilized years ago. Interesting, that relates to work that was done in plant pathology probably 50 years ago, showing that pine bark compost suppresses a lot of soil-borne pathogens, some of the pine bark compost. So I don't know if there's a hardwood softwood mix. I don't know what the mix was actually.
Okay.
Just on that previous question about the trichodermas, I've done work in New Zealand with bark. It was Trichoderma hartzianum. I've done work in UK with bark. It was Trichoderma hartzianum. So I would be pretty sure it's something like that. I'm skeptical it will be Trichoderma aggressivum.
I agree with you, Ralph.
Trichoderma hartzianum likes growing on bark, whether it's New Zealand or England. So probably American bark is susceptible to that as well. I'd be surprised if it's aggressivum, which is much more homed in on the mushroom rather than the organic material.
Yeah.
Okay, another question coming in here. What percentage of peat supplies from Canada to the US have stopped? I think you did mention this briefly, John.
Of the peat supply that was coming into the Pennsylvania growers, I don't know the absolute number, but I've heard estimates that it's been more than a third of our peat supply was shut off by that one company when they said they weren't shipping it down, up to 40% potentially. And I don't know right now if, I'm not involved with the business end of it as much, if they're able to obtain that difference, that shortfall from the other peat suppliers or not. That's a big demand. That's a lot of peat moss that was coming across the border that's no longer coming down.
Yeah. Okay. So question here, Trichoderma are commonly no, sorry, I think, is it possible that green mold observed when using the material origins from the living plant? Sorry, I'm just not too sure what that question means.
Well, that's a good question. So the thing we're testing right now is we're not screening the material that came in to see what's in there. We're just doing some inoculations to see if it's more susceptible at all. Again, this was kind of a rapid, unfunded desperation experiments, like what can we use? I don't know personally. Trichoderma is everywhere. It can be found everywhere. So I'm not sure if it's in their processing center, if it's in the material coming in. I know it's in our research center in the attic ways. When we start disturbing things, it's everywhere. So I don't know the origin of it yet.
Can I just
add?
Sure
if it's something sorry, Helen. I'm not sure if it's something if you heat treat it, that would take care of it. But again, that's an added cost and an added expense to the grower.
Just to say there as well, John, trichodermas are common on wood substrates. They're cellulolytic, so they like that substrate. We also know that there's a range up to maybe 10 different species that we might encounter in a mushroom environment, including Harzianum. So yeah, most of which are not that detrimental, may cause a bit of spotting, but they're not as detrimental as aggressivum. So it's just a matter of finding out what these are and how we might control them if we have to use casings that support their growth more readily than the current casings. Yeah,
right. And Helen, from what I saw, that's my feeling. That wasn't aggressive. Yeah. It's that spot trike you see typically later breeds.
Yeah.
Okay, and just another question here. Did you adjust the moisture content of the wood fiber mixes to 80%, similar to the casing material we use currently?
We adjusted the moisture to our standard set point up front, but it didn't seem to hold it as well. That's why I said it took a little bit of a learning curve. It seemed to want to dry out quicker when you physically looked at it. So we were putting additional waters on it. And the last time we incorporated this into a crop, we took a little different approach and watered it much heavier up front and then scratched it after we pushed the water into it on the beds. And this last crop, actually, the moisture probably looks as good as I've seen in it. And right now we're probably like day 10 case hold with it. Mm-hmm. So yeah, we spot adjusted water differently during the case hold and cropping. We calculated and brought the moisture to the same set point relatively at the start.
Mm-hmm. But I suppose, John, if you just look back at trial run from your slides, that might explain why the yield has sort of fallen off in the second flushes. It'd be probably one of the reasons why.
Well, I'm pretty sure it was due to bed damage that we saw. I mean, yeah, it was drier, but there was, to me, because it ran drier early, we had a heavy pin set. I think we saw more bed damage because it's clumpy and it's hard to pull them off without disturbing the casing too much.
Okay, just another question here. Question to Ralph. So with green waste, are there issues with contaminants, agrochemicals, heavy metals?
Not so much heavy metals or the main contaminant would be things like glass, plastic, that could be very detrimental if you were growing mushrooms in there. So the quality requirements for casing, because the crop is growing in contact with the growing media, are probably even higher than something that just uses a potting compost. And one glass bottle in somebody's green bin makes a lot of shards of glass, so that's a big problem. Getting the quality high enough to be used as the casing material. I don't think heavy metals would be the major problem. It would be physical contaminants, plastic and glass, that would be the main problem.
Okay. Okay, great. Thanks for that, Ralph. And I don't see we've no more questions coming in. But if anyone has any questions after the event, you know, they can send them to myself, and I can direct them to either John or Ralph after the event, and we'll try and answer any questions you have. So without further ado, we'll end the session with John, and we'll move on to Lael Walsh. So Lael is a research officer here in Teagasc in the Horticultural Development Department. So Lael is one of our lead researchers in the S-Transit project, which aims to support sustainable transition away from peat use in mushroom casing. So Lael will now give a short update on the project, which has recently commenced. So I'll hand you over to Lael. Perfect. Thanks for that, Lael. If you can come off mute.
Hi everyone, can you hear me?
Yep, perfect.
Yep. Can you see my presentation?
Yeah, if you just go to presentation mode.
Great.
Perfect.
Thanks, Donal. Hi, excuse me. Hi everyone, it's great to be here today. I'm Lael Walsh. I'm a research officer in Teagasc, focusing on sustainability and horticulture. I'd like to talk to you today about two projects. The first one is the S-Transit project. We're looking at supporting a sustainable transition away from peat use in mushroom casing, and that'll be the main focus of my talk today, just to give you an update on the project and what we plan to do. It's only recently started in October. I'll also give a brief update on the second project, which has commenced recently in the last month. That one is called Beyond Peat and is not necessarily focused on mushroom casing, but on horticultural growing media in general. So as you know, the Irish professional horticulture use requires very low levels of peat. And there was a recent review by the Horticulture Peat Working Group, which found that professional use of horticultural peat is only about 4.2%. So it's very low in comparison to other demands for peat, like energy or export or heating or things like that. That equates to about 376,000 cubic meters of peat required for horticultural use. It supports the horticulture sector, which is the fourth largest sector in Ireland, valued at about 477 million. And in terms of the breakup of the use of peat, it tends to be attributed to professional use of peat, mushroom casing, and then exported casing to places like the UK. So that's the context that we're working in terms of trying to address this idea of peat use in horticultural growing medias. But there are two sides to the story. There's obviously the economic side, where Irish horticulture is very reliant on peat to achieve the yields that we've become accustomed to. And comparatively, as I said, peat use in horticulture is relatively low. But we're also taking on this challenge at a time which is quite economically challenging for growers in Ireland and in other places in the UK as well, at a time when energy and input costs have risen quite significantly. So we have quite a challenge on our hands to transition away from peat use in horticulture growing medias. And then this issue of resilience is the idea that we don't want in future to maybe rely on just one peat replacement alternative. We want to build resilience in the system where we have a number of materials or options available to growers, and that creates a resilient system. We're not in that situation right now. We're largely reliant on peat, but we want to get to a situation where we can become more resilient in terms of horticulture growing media. So what we're presented with here is really a research challenge. We've spent a long time, as Rolf touched on earlier, since the 1960s, kind of preparing and researching and optimizing growth in peat conditions. And now we're trying to move away from peat. So we're really presented with a research challenge here in a fairly short space of time. You know, we have targets, and, you know, I think in the UK, 2027, 2028, or 2030 to actually transition away from peat use. So it's quite a challenge we have in the next 5 to 10 years on our hands. But the other side of the story is the environmental side, and there is it's a national policy issue, particularly here in Ireland, that we need to reduce our reliance and our use of peat across the board, be it in energy or environmental use. There are certain climate actions that have been set out, and this is around the idea that we are currently in a climate emergency. Peatlands do sequester carbon, and you know they do support a lot of biodiversity. So we have to be aware that there's these two sides to it. There's the environmental and the economic side. So like I said, I'd like to talk to you a little bit about the S-Transit project. This is the project specifically focusing on transitioning away or reducing use of peat in mushroom casing. And what we hope to do here is to provide information to help the mushroom sector sustainably transition away from peat use. So I present to you a framework there on the right. We want to look at options that are sustainable, and there was a question earlier about greenhouse gas emissions. That's something we will consider in the options that we're considering as peat alternatives. We obviously want to focus on performance because that's really important for our growers and to achieve yield. And then we also want to focus on what can we source locally or within proximity within the EU, not looking at options that might be coming from further afield. So like I said, we want to identify these peat alternatives or peat reduced blends with good performance. We'd like to characterize and quantify the physical and chemical structure and properties of these materials. And we would like to make recommendations and generate data that can support some of the recommendations that we have. So the project is broken up into 5 tasks. And the first task is really to interrogate the literature. We're undertaking a systematic literature review and meta-analysis. And this will be looking at options like what is locally available in terms of maybe bark, what are the physical and chemical properties of these materials, and most importantly, what are the sustainability credentials of these things. Another point to make is that there is competing pressure on some of these feedstocks like wood fibre or wood bark and things like that from other sectors as well. So we want to understand what are the market pressures as well to try to understand if these options are viable and will continue to be viable into the future in terms of these competing interests. The next 2 tasks in the project, tasks 2 and 3, is to actually develop the mushroom casing mixes. And there's a picture there at the top right. This is some of the work we were doing just this morning, doing some pH testing on some of the options that we're starting to trial in our mushroom unit here in Ashtown. But what we hope to do in this task is develop a series of experiments, either in the mushroom unit itself or maybe in the lab, or a series of microcosm experiments and growth trials to try to evaluate the performance of these different casing mixes or options. And one of the main the main tools that we'll use is to characterize some of these physical properties using X-ray CT scanning. We'll be looking at things like the mycelial growth responses to the physical casing structure and aspects of moisture and water holding capacity as well. And then we hope that once we've kind of whittled down these options from our meta-analysis and our testing options, we might identify, let's say, 1 or 2 options that might be seen to yield quite well and might be seen to have great sustainability credentials. And we want to actually scale this out at a commercial scale to assess, can we produce these blends or these mixes at a commercial scale? Can we produce mushrooms at a commercial scale? And this is where we hope we can engage a little bit more with our stakeholders in Ireland in terms of casing producers and maybe even mushroom producers in terms of validating some of these options that we find. And this is the part that I suppose I'm most involved in, given my background in sustainability, is to actually conduct a life cycle assessment and consider the environmental footprint of some of the options that we've trialed. So the framework I showed you was looking at locally sourced options, looking at options that had good performance, but then to also look at the sustainability or environmental credentials of these options and to undertake a full life cycle assessment. This is an area we don't know a lot of information about. We don't have a lot of data, including in an Irish context. So the idea here is that we would look at all the inputs into the creation of these materials, all the processes that might be going in terms of energy and manufacturing and resource extraction, and then the outputs in terms of what we're actually creating in terms of that material. So we'll look at things like defining our system boundaries, where will we start to measure and where will we stop to measure some of these inputs and outputs. We create inventories and collect data and generate our life cycle assessment models to actually compare these non-peat or peat reduced casing options to our standard peat control. And then the engagement and dissemination is obviously very important to us, and we'd like to engage with our stakeholders like we're doing today. And I'm delighted that I've had a chance to talk about the project so you know about the research that we're undertaking. We'd like to bring the sector along in the journey, including in highlighting options to us that might be worth testing in terms of this project as well. And what we really hope then is to provide this invaluable information to growers and actually support the sector in terms of the sector itself, but also in terms of policymakers trying to drive certain policies around climate change and things like that, with actually providing some of the data that helps with transitioning away from peat use. I'd like to highlight that this is not my research, it's undertaken by a team. Most importantly, our lead researcher and our PhD candidate, Gabrielle Young, who is funded by Teagasc under the Walsh Scholarship Programme and undertakes her research at University College Dublin. But Gabrielle is supported by a team of task leaders or advisors, which include researchers in the soils and meta-analysis and X-ray CT scanning departments at UCD, but also Helen Grogan on the call and Donal Gernon on the call today. Myself and Rolf as well are involved in the project. And then Dr. Michael Gaffney in terms of the collaboration we have with Beyond Peat. This work wouldn't be undertaken without a group of researchers that help us with crop management and training, and I'd like to thank them as well, who might be on the call listening to us, and they've really helped us in terms of planning and setting out some of the trials that we'll be undertaking in this project. But before I go away, I'd like to tell you a little bit more about the Beyond Peat project, so just a couple of slides. The Beyond Peat project is a Department of Agriculture, Food and the Marine funded project to the value of 1.69 million. And here we're hoping to look at assessing current alternatives to peat across horticultural growing media. So we're moving beyond mushroom production here to look at supporting the nursery stock sector, the vegetable sector, and so forth, okay? And here we're looking at a framework of looking at what's agronomically has potential, what's economically viable, and of course then what is environmentally sustainable. So here we hope to utilize bioresources and novel technologies, so existing options that we might be able to reconstitute into growing media, but also developing maybe novel technologies in terms of polymers that we might be able to use across horticultural growing medias, including mushrooms and other types of horticulture production as well. So again, here, a life cycle assessment is a big component of what we will do. It's no good maybe just evaluating the performance and the access of the materials. We also want to understand that they are environmentally sustainable. This is a project, it's a fairly large project. It'll be undertaken over a longer 5 or 6 year period, and it involves a number of stakeholders or partners in Northern Ireland, AFBI, a number of partners in Ireland as well. And this is led by Teagasc. Dr. Michael Gaffney is the coordinator of the project, and then Helen Grogan and I are PIs in that project. So we have started some work where we've looked at a rapid review of recent published studies from Irish institutions, just to get an understanding for what work has been done in Ireland so far around peat replacement or alternative growing medias. And we found a number of things which range from green waste compost to spent brewery grains and coir and wood fibre and hydrochar and so forth. And the objective here now is then to kind of whittle those down to see, well, are those available to horticulture? Are they available in a cost-effective manner? And what do we need to do to transition them or to process them to make them suitable for horticultural growing media? A lot of the issues that some of the two first speakers have touched on, these materials tend to be highly variable. They might have high nutrient contents that make them unsuitable. So we need to kind of understand a little bit more about what we need to actually do to process these materials to actually get them to a point that we might be able to use them in growing media. So there are two pillars to the project. Essentially, we're looking at existing alternatives and we want to assess them using, again, our framework of agronomic, economic and environmental impact. But we also want to create new and novel growing medias, maybe looking at how we could optimize certain composting processes, how we could transform certain waste materials, and how we might be able to generate different types of new and novel biopolymers or synthetic polymers as well. So the current environment that we're operating in is that the horticulture sector operates with very low margins. They're affected by rising input costs, which is quite a challenge. There's currently no realistic widespread replacement available for horticultural peat in general. So again, it is a research challenge that we have on our hands. And really growers need time, I think, to support this transition and make this change as well and adjust a number of things that they've become accustomed to over time in terms of their fertigation, watering, and fertilization treatments as well. So there is a substantial research focus required to actually help growers to make this transition. But I'd like to say that work has started, and there's a picture there of myself and two other researchers, Brian and Gabrielle, this morning. We were preparing a non-peat mushroom casing that we'll be testing out in our mushroom unit throughout this year. So that was our first go at replacing things. So we're just delighted to get started. We're delighted to be here today to tell you more about our research. And thank you so much for listening to the presentation.
Thanks very much, Lael. That's a great summary. I think you've given both projects, and it's great to see that we're in this space and that we are trying to address the problem. And I think I was very impressed with the structure of both projects. They're very well structured, and it's good that there's two projects running alongside each other, and we won't be duplicating work here. So it's very exciting, and look, hopefully we get some good results out of it that can help the industry.